Hello, welcome back to Cracking the Cryptic. It was Chip Saunders' birthday on Wednesday, but he was working, so the celebration was postponed until today. And Chip has been having a meal out with his family and then back home for a quiet one with some assorted cupcakes. So we'll hope the ratio of icing to cake is the appropriate 1-to-1 ratio. And we'll hope that Chip has a lovely evening, and we'll have a look at his episode 16 of a series he's been doing. This one is called The Loneliest X. There's a lot of I think the series is all about German whispers plus one extra clue. And the one extra clue really is one extra clue this time. There's just one X in the puzzle. So we'll have a look at that in a moment. But happy birthday, Chip. Thank you for writing to us and for sending us puzzles to do on a regular basis. We're going to have a look at this one today. We're going to tell you first about Duality by Skunkworks, which features a lot of dual constraints, and that is on Patreon. That's the monthly reward. It's open as a competition till the 20th. Oh, I believe Simon has been in contact with Beatrice, the last competition winner, and we'll be trying to produce a solution video for soon, a collaboration video with her, so that'll be exciting. Now, what else we got going on Patreon? We've got Gridogram and Connections and the crossword solves that we do occasionally. There was one this month, so check it out. We've also got lots of apps, and they do feature line Sudoku and domino Sudoku, as well as classic Sudoku, and classic Sudoku 2 is the latest, and the Worms. So do have a look at those, all good fun. But if you fancy trying a puzzle, Chip's normally fairly approachable, so give it a go on the first link under the video. Do you know what? I was just starting the puzzle and I forgot I hadn't done the rules. So I'm going to do the rules. Apologies. So normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. Digits along adjacent digits on a green line must have a difference of at least 5. Cells separated by an X, there's only one of them, summed to 10. That's it. Those are the rules. It's not much. It's enough to solve the puzzle, that and the 4 given digits. Do give it a try. I'm going to restart the clock now and start again. And I hadn't got anywhere. And let's see how we do. Let's get cracking. So I was just going to go through the explanation of certain things we know about green lines. One is that 5 can't appear on a German whisper line because its neighbour would have to be 0 or less or 10 or more, and they are not Sudoku digits. Now the next thing is that therefore these lines alternate between high and low, higher than 5 and lower than 5. So these reds will all be either lows and the yellows highs, or the other way around. In fact, the yellows form a complete set of the 4 either high or low digits. The third thing that I do sometimes tell you is that 4 and 6 can't be placed in cells where their 2 neighbours see each other. So that would include this one, where those 2 cells are in the same column. So if that was a 4, they would both have to be 9, and that wouldn't work. Now, how can we relate the colouring on this line to any of the other lines? These ones will be either 1, 2, 3, 4 or 6, 7, 8, 9. And these will be either 1, 2, 3 or... Oh, they can't be 1, 2, 3 because of this 2. Right, these lines, these reds are in positions, as it happens, where they cannot be 4 or 6. So this either has to be a set of 1, 2, 3, which it clearly can't be, or a set of 7, 8, 9, which it therefore is. I'm going to turn the reds into orange. Oh, should have been very obvious. Took me a moment. I'm going to turn the yellows into blue for low and put in 1, 2, 3, 4. 2 of those can't be a 2 because of Sudoku. So the 2 in this section is in this group. And these 2 can't be 4s because they both have 2 neighbours. Therefore, the blue 4 in this central column has to be in one of these 2 cells, and that must be touching a 9 either there or there. And that means this digit can't be a 9. I almost want to say it has to be an 8 so that we can accommodate a 3. No, that's not necessarily true. If you had 4, 9 at one end of the line and 3, 8 at the other, this could be a 1, 2 pair surrounding a 7. So that would be incorrect. Now, what about row... row 3, right. If you've been shouting at me to look for 5 in row 3, you're right. Because 5 can not only not go on a green line, it can't go on an X, because it would have to be next to another 5 on the X. And that would break Sudoku rules. So we can put a 5 into the only completely white cell in this row. And we've got pairs along here. So I was using yellow and red earlier. Yeah, this is good. I was using yellow and red earlier to indicate high and low in unknown order. So that's one of each. This is one of each on the X. That works a bit like a green line connection. It's different, but it's similar in that there must be one high and one low. And if you think about the possible pairs, you'll see that they all fall into that category. 1, 9, 2, 8, 3, 7, and 4, 6. Now, this pair must be one high and one low because they're next to each other on a whisper. And what we have learnt from this is that these 3 dominoes contain 3 reds and 3 yellows. Now, I don't know whether red is high and yellow is low or the other way around, but I do know that we must have used up all 4 oranges in this row. I don't know whether yellow or red is going to become orange, but one of them is. And with this one, we'll have used up all 4 oranges, but therefore this must be blue. It's not 5, obviously. Now we can alternate on this line. Blue, orange, blue, orange. I wasn't expecting this line to be the one that we first discovered the polarity of outside the central columns. Does it help? Not dramatically. This digit is 1 or 3. It's low. This one could actually be 6 because they could be 1s. I wonder if I'm failing to use the given digits. Where's 2 in row 3? It obviously isn't in that box and it's not there. So it's either here or in one of these cells. I'll tell you what I'm going to do. I'm going to uncolour some of these cells and then I'm going to colour this full line, being about the longest that we have available. So I'm just going to choose red and yellow in a random order. Actually, yes, I can colour this cell on the X as well. Now, both of these positions can't be 4s or 6s. This one sees 2 cells in the same box. This one sees 2 cells in the same row. So if they were low, I don't know. Oh, I could colour these given digits, couldn't I? I always forget to do that. Let's do that just in case it triggers something at some point. This box, oh, this column. Yeah, we've got quite a bit of information in this column. So we've got 1 yellow and 2 reds done. These are going to be 1 of each as we go down the column, because obviously a pair next to each other on the same line is 1 high and 1 low. Now that's going to mean the remaining 2 cells are a yellow and a 5. And this final column has only 2 places for 5, but they are slightly different places. We don't get an X-wing. We do get 3 dominoes of 1 each. So the other digit here will be the opposite to that. That's not very informative. I don't know whether I'm next meant to do something with numbers or with colouring. So let's just study the grid for a moment. Oh, we had a 2 in one of those cells. Ah, there we go, that's it. We're placing 2 in this box. There's a 2 in one of those cells, so these are ruled out. These are all ruled out by given digit 2s, and that is the only place left for 2. And now we know that yellow is blue. and that red is orange because 2 is always blue. I'm tempted to write 2 in there, but I'm not going to. Now, this digit is not a 4 here in this position because it has 2 neighbours that see each other. So that's 1 or 3. On the X going with 7 or 9. This digit is not 6 because it's sitting next to 2. So we've got 7, 8, 9 triple. And this pair must include 6. 6 and 6 always goes with 1 on the line. 6 can't go here because both of those would have to be a 1. So this is 6, that's 1, and we can colour this line as well. And now the colouring is really taking shape in the grid. That digit becomes a 3 because it's not a 1. I was very tempted to write a 9 in here on the basis that all of these connections were German whispers, but this is an X connection, so that's a 7. This is a 4. 4 is always attached to 9 on a line. This low digit sees 1, 2, and 4, so that's 3. 3 touch it. Oh, that's 3 in the corner. That's 3 in the spotlight, losing its religion. 3 is always attached to 8 or 9, and we've had a 9 in the column. So these remaining digits in the box are 5, 7, and 9. We've got an 8 here. 7, 3. This is high, and it's touching a 3. So that's 8 or 9. Oh, well, we know which one it is. It's 9. There we go. That now becomes a 9, and this is not a 9. And now this digit can't be a 4, and now the one of these 4 blues that can be a 4 is at the top. That 7, 8 pair, this digit can't be 3 because it would have to be touching a 7 in one of those positions. Oh, 1 is looking at that cell, so that's a 3, surrounded in its box by 8 and 9. This digit becomes a 7, surrounded in its box or along its line by 1 and 2. That digit becomes an 8, and this has now become a 3 because of that 1, 2 pair. And we're doing well. This is touching a 2 on the line, but it can't be 8 or 9 by Sudoku, so it's 7. This is low and not a 3. That's not very helpful. 6, 4, 2, 5, 9. 3, 8. 8 and 7. Oh, look, that is a naked single. It sees 7, 8 in the column, 3 in the row. So that's a 1. This becomes a naked single 3. I remember to colour them. And these are 7 and 8, I think. Good progress again. The remaining digits in column 6 are 4, 5, 6. We're going to somehow have to get out of these top rows and convert what we've done into the bottom section of the puzzle. This column was interesting. 4, 5, 1, 2, 3. I mean, these are all high. That much I know. This one is 6 or 9, and these two can't be 8. So the only place for 8 in this column is there at the top. That's a 7. This is a 5. That's going to give us some colour up here. And these digits are now 2, 4, and 5. The green line can't be a 5. That one can't be a 2. This is a 1, 6 pair that I can't resolve. But that's good, good stuff. Right, now, this pair, the high digit is going to be 6 or 7 on those. I was going to say, therefore, the low digit is 1 or 2, but in fact, just by Sudoku, the low digit is 1 or 2. If this is high, it's... that's perfect. This can't be high, this cell. I'm going to colour it blue. Why can't it be high? Because it would have to be 6 or 7, and then it would have to connect to 1 or 2. But that is not possible because of the 1 and 2 we now have in the grid. So this is low and is 1 or 2. And this high one could be any digit. But that being low tells us something about the column. It tells us that these two, one of them is orange, indeed is 6 or 7, and the other one is a 5. So I'm going to note that. Now, what did we have over here? We had that one of these was blue and the other was 5. I don't quite know how to work that into the puzzle. How about the bottom row? Do we have enough information? 3 alternating blue and orange cells here. They could have 2 oranges as long as that was a 5. Yeah, I don't know. That doesn't do it. Right, the high digits on this pair are 6 and 8. Now, what do we know about that? One of them is going with a 1. But the 8 could be the 8 could be going with a 2 or a 3. I don't know. So, okay, one of these is a 3. That's just a bit of Sudoku. 6, 7, 2, 7, 8, 3. This middle row. 5. Well, yes, this is a great cell. Right. By Sudoku, this could only be 1, 4, 5, or 6. It sees 2, 3, 8, 7, and 9. It can't be 5 on a green line. And in this position on a green line, seeing 2 neighbours in the same box, it can't be 4 or 6. That digit is actually a 1. Now, these 2 both need a high digit on. That digit, indeed, is the high here. And what we've just worked out is that in these 2 pairs, one of the high digits is a 6. The 6 is going to have to sit next to 1. So that must be here. The 1 is there. This is the 6. This pair includes an 8. We know exactly where that goes. And now we can colour these lines completely with alternating blue and orange colours. And we've almost got all the lines in the grid coloured now. This digit, I feel, is going to be a 3. Well, no, it's 2 or 3 at the moment. That doesn't resolve it. This digit, this sees 3 and 2. So this has to be a 1. This digit sees 1, 2, and 3, but it's low. So that's 4 touching a 9. And these lines are all coming together now. That 1 looks up here. We get 6. Sorry, I slipped. We get 6 and a 1. That's orange. That doesn't do much else. This is now low, but it's not 1 or 2. In this position, seeing 2 neighbours that see each other, it can't be 4. So that's 3 surrounded by an 8, 9 pair. And now we know where 3 goes in the central box. And what else does that do? Okay, I'm going to look at Tiddly line here. This digit sees 2, 3, 4, 6, 7, 8. It can't be a 5 on a green line. So that is extreme. That is 1 or 9. That's not going to help me resolve this one, which sees 1, 3, 7, 8, 9. Can't be 5. So that's 2, 4, or 6. This is not a position where 4 or 6 are a problem, particularly with an extreme digit there. So that line was not worth investigating at this point. This line, we haven't resolved this. 3, 8, 4, 9. Maybe we can do something like this first. 6, 7, 2, 3, 4. No, this box, this digit is 4 or 5 because of everything else it sees. So is this one. This sees 8 and 9 in the column. This sees 8 and 9 in the column as well, actually. So that's a 4, 5 pair. And that gives me an 8, 9 pair in this column. And these are from 4, 5, or 7, and definitely include a 7. Now, I was hoping this row would bear fruit. This digit is 5 or 9, but this is what we call a chocolate teapot situation, because these... No, it's not. It's not at all. That's a 5, 6, 9 triple. A chocolate teapot situation is where You get pairs in cells, and they are such that they're useless, like a chocolate teapot, because they don't resolve themselves. But that is not the case here, where we have a 5, 6, 9 triple, and that's the only place for 4. This digit is now a 5, and that means this one is not a 5 and is blue. And do we know what digit it is? Yes, it sees 1, 2, and 4. So that's a 3. Now, oh, and that's 3 in the corner. That's 3 in the spot. Light again. Right, I hoped that was going to resolve this, but we didn't. If 5 had gone in there in the first column, it would have resolved where 5 goes in this final column, but going there, it didn't. It does say that can't be a 5. Right, I'm looking at this bottom row now. 3, 1, 9, 4, 2. That digit is 5 or 7 by Sudoku. It can't be 6 or 8. So what that teaches me is I know where 8 goes in this row. It must be here. In fact, I was wondering if that's the last 8 in the grid. It is once I work out where to put 8 in this box, which is now obviously not in those cells. So it must be there. Then we get 8 there. Now we've got all the 8s in the grid. This digit becomes 9. That apparently just tidies up that area without actually resolving anything else. For this to be high, it would be the last high digit in the column, 7 or 9. That would make this 5 and turn this into a 6, 7 pair. It's possible. I'm sure this is fairly straightforwardly resolved. That digit seems to have to be 2 or 4 by Sudoku. This can't be 6 anymore. This is 1, 5, or 9. Maybe I'm missing a whisper issue. If I am, I think it's in this box. Right, what about this one? 5, 1, 3, 8. It's in a position where 4 and 6 couldn't go because of the 2 neighbours situation. So that is 2, 7, or 9. If it was 2, it would be surrounded by, this would have to be a 7, because it can't be anything else if it's a 2. Then that's a 5, that's a 6. This would have to be a 9. So this would be a 2, 9 pair. That would break because of this. Oh, that's weird. Maybe it doesn't need to be this convoluted, but it's very clever actually. So if this digit was 2, on the whisper that would have to be 7. Because that puts 5 and 6 down in these cells, the only high digit that could now go here is 9, and the only digit that could go here, assuming that's a 2, is a 1. So now you've got 1 and 9 here, and that breaks this cell. So this is not 2, it's high. Now we can colour this line and indeed reduce the candidates within it. So we've suddenly found a 1, 2 pair there. That means this digit, which isn't 3, is 4. That has to sit next to 9. Lots. That makes this a 1. That makes this high. That makes this 5. This one is 2. That's 1. This digit is known. It's 7. That can't be 3 since we got the 3 in the corner. I hadn't noticed that. That gives us 4, 5, 2 at the top. If I keep colouring, and I'm probably committed to it at this stage, then we're ending up with this situation. This digit is not coloured, it's 5. That one is 4, which is blue. This is about where I normally colour a digit the wrong colour, because it just doesn't matter and I don't really notice. I mean, it's not an excuse. It's just the reason it happens. Right, 4 and 6 there are both blue, and 4 is looking at this cell, and everything is getting resolved. Apart from that 6, 7 pair in the first 6 columns, everything else is done. 7 and 9 there. 4, 6. I'm about to dissolve into fits of coughing. Let's see if we can finish this for... Oh, red. Red was not what I was after there. 7, 6, 7. Excuse me a second. I'm so sorry. Very poor timing, but if I'm going to complete the colouring, I have to have a few seconds left at the end. That's going to be a 1, this is a 5, and that finishes the puzzle. And it's the Lonely X is solved. So there we go. Thank you so much to Chip for sending that through. And very happy birthday to you. I hope you've been enjoying your cupcakes, especially by now. And if you haven't, dig in. Thank you so much for sending the puzzle. And I hope you guys had a go at that, especially if you don't normally tackle these. Good fun one with some very neat deductions along the way. Hope to see you again soon on the channel. Bye for now.